Hello everyone, welcome to my channel. I am still busy with integration, and in this video I have two integrals that I would like us to look at. The first one is this one here. It's the integral of dx all over e to the power x minus 1. We are to integrate this expression here. Now, how do we go about this? Well, here is the approach. Our first integral, it's the integral of dx all over e to the power x minus 1. This is page 1. Now, if you have watched some of my previous videos, I've spoken about what I call the special one. It's a technique that we employ to be able to evaluate some rather complicated integrals if you are not very careful. So in this case, we are going to introduce e to the power minus x in the numerator and in the denominator as follows. This is the same as the integral of e to the minus x dx. We're dividing this by e to the minus x multiplied by e to the power x minus 1, like that. Just want to remove this part here. Right. Next, we have to remove these brackets. In other words, distribute e to the power x as follows. This is equal to the integral of e to the power minus x dx all over. When you multiply these two, the powers add. So minus x plus x is actually e to the power 0. And then we have minus e to the power minus x, like that. And e to the power 0 is 1. So this is the integral of e to the power minus x dx divided by 1 minus e to the power minus x. Brilliant. Now we can use u substitution now. So we're going to let u be equal to the denominator 1 minus e to the power minus x. And we have to differentiate u with respect to x. So du dx is equal to, remember, derivative of 1 is 0 because 1 is a constant, and derivative of e to the power minus x is minus e to the power minus x. So we have minus e to the power minus x, like so, which simply gives us e to the power minus x. Right, now I have to multiply by dx both sides. We move to page 2. Page 2. So now I'm saying what we have is multiply by dx both sides. So what do we have? We have du is equal to e to the power minus x dx. Now if you check in the numerator of our integral here, in the numerator there we have e to the power minus x dx, and that's what we have here, and the answer is du. So we are going to have to replace this expression here by du, and in the denominator we just have u there. So we're basically saying that integral changes to the integral of du all over u. Let me just show you again. This expression in the numerator is actually du according to this equation here, and in the denominator you have 1 minus e to the power minus x. Remember, that's our u. So the integral changes as follows. We can rewrite this to the integral of 1 over u du, and you'll agree with me that this is just natural log of u, and we have to say plus c because our integral is an indefinite one. Now u is not our original integral, original variable. We have to go back and see the connection between u and x because x is our original variable. So here we go. U is equal to 1 to the power 1 minus e to the power minus x. So basically the connection between u and x is this one here. Where I see u, I must have it replaced by 1 minus e to the power minus x. So basically this is equal to natural log of 1 minus e to the power minus x plus c. I want to simplify this a little bit further. So this one here, remember, you can write it as natural log of 1 minus 1 over e to the power minus x, e power x, laws of exponents, remember that, plus c. And therefore I want to write this expression here as a fraction, a single fraction, basically with one denominator, obviously. So this is going to be natural log of, watch this, how I'm going to change it, e to the power x all over e to the power x minus 1 over e to the power x plus c. Obviously, that's your 1. But now I can put the two terms together. What do I have? This is page 3. Just to finish this off now, you see shortly what I'm trying to achieve here. So what I'm saying now is, what we have there is that equation inequality. This function here is expression is equal to natural log of, watch this, e to the power x minus 1 all over e to the power x plus 1 plus c. Now, using laws of logs, a specific law of logs I want us to use is this one here. Log of m over n equals natural log of m minus natural log of n. This form of the log is what we have here. Two terms dividing. So basically I can say this is equal to natural log of e to the power x minus 1 minus natural log of e to the power x plus c, and you'll agree with me that this is just x. So what we have now as our final solution is natural log of e to the power x minus 1 minus x plus c. That's our final solution to first integral. Just remind you, our first integral is this one here. So that's our final solution. Now moving on to the second integral in this video. Our second integral is this one here. Allow me to move to the next page. There is our second integral. It's the integral of e to the power the square root of x plus 1 all over the square root of x plus 1 dx. Basically, they are positive square root. Now, so this is going to be our page 4 now. How do we approach this? Page 4, the second integral. It's the integral of e to the power positive square root of x plus 1 all over positive square root of x plus 1 dx. Now the approach to this one is, let me rewrite it first. This is the same as the integral of e to the power minus e to the power square root of x plus 1, that's the positive square root, times dx all over positive square root of x plus 1. There's a reason why I'm writing it like this, because now I'm going to have to say let u be equal to the power of e, which is square root of x plus 1, positive square root, that is. We can rewrite this as, watch this, we can rewrite this as x plus 1 to the power half, like that. And why am I doing this? Because now I want to have to differentiate both sides. So du, dx, we're differentiating u with respect to x. You'll agree with me that I'm going to have to apply chain rule there. Differentiate the function first. We have 1 over 2 x plus 1 to the power half minus 1, and then we have to multiply by the derivative with respect to x of x plus 1. That is chain rule for you. And so on the right hand side, we simplified to half x plus 1 to the power minus half times 1, because derivative of x is 1, derivative of 1 is 0. 1 is a constant. Rewriting this, remember we have du dx here. Now I'm going to have to multiply both sides by 2, so I'm going to get 2 du dx is equal to, and I'm going to have to rewrite this expression to 1 all over x plus 1 all to the power half. Right, I'm going to have to multiply by dx both sides and rewrite this as square root of x plus 1. Taking us to page 5, just to finish this off. Taking us to page 5, right, and rewriting that expression, which you can see, I'm saying basically that what we have now is 2 du is going to be equal to dx all over square root of x plus 1. Now you understand why I had to rewrite the integral into that form, because this expression now is this one here, which is 2 du, And here we just have e to the power u because a square root of x plus 1 is u according to this part here. So now our integral changes as follows. We can say that what we have now is the integral of e to the power u times 2 du. Take 2 out because 2 is a constant. We have e to the power u du, and integral of e to the power u is just e to the power u. So this is 2 e to the power u. I have to say plus c because our integral is yet again an indefinite one. But what is u equal to? U is equal to square root of x plus 1, positive square root, that is. So this can change to 2 e to the power, the positive square root of x plus 1, and then we are going to say plus c. This is the final solution to our second integral. I am going to stop here. If you are new to this channel, support us by subscribing, and we truly value your feedback as well. All right, God bless you in the next one.